Hello, everyone, and welcome back again. My name is Keith Gebhardt, and in this lecture, we are going to cover the TCP/IP network architecture model. The Transmission Control Protocol, Internet Protocol, is also known as the TCP/IP network architecture model, is the model that we use today. Now, we can prove this by taking a look at our network interface card on my computer here. If I go into my Network and Sharing Center, change network adapter settings, and just go ahead and check the properties on any of my adapters on my computer here, we can see we are using IP version 4, which is the TCP/IP v4. Just pay attention that there are two different versions. We have IPv4 and IPv6. Now, we're not going to cover IPv6 in this course, but it is something you will need to familiarize yourself with for studying Cisco exams. Now, we have two versions of the TCP/IP model, the original 4-layer model and the updated 5-layer model. Today, we are using the 5-layer model on our networks, and it will be the only model we cover in this course. Now, just pay attention to how they are very similar. The only real differences are that from the original, they split the layer 1 into 2 and changed the internet layer from internet to network. Now, you will need to know the differences between the two TCP/IP models for your Cisco exam. Here we can see how the layers on our TCP/IP model are almost identical to the layers we had on our OSI model. The only difference is that layer 7 from the OSI model now became layer 5, and that the session and presentation layer no longer exist. Now, although we don't see the layers didn't just disappear. They basically just consolidated them all into layer 5, our application layer on the new TCP/IP models. Now, although we have 5 layers here, we only concern ourselves with layer 4, 3, and 2 for the physical data encapsulation process. But again, it is very important to understand all 5 layers because they all tie into the encapsulation process one way or another. Let's go ahead and take a look at the first step here. We have a segment, and notice it is layer 4. Our layer 4 segment is the transport layer encapsulation, which encapsulates our application layer and data into a segment header. So what does that mean? Well, if we go up here and we say, okay, we're going to use the HTTP protocol with the data associated with it. So I'm just going to write data in here as neat as I can. This is now going to need to be sent down to what? Our transport layer, because it needs to figure out how it's going to communicate through the network. This transport layer is our segment, okay? Now, it's going to take the HTTP and the data and put it into this, what's called our data block. Now, the segment is also going to add what we call a header. This header encapsulates all of this information into the data block. Once that happens, it gets sent down to our network layer. Now, you can see our network layer is what we call a packet, and it encapsulates all of the information not only from up here, so all this information got sent down into this data block here. Our packet is going to take all this information plus this information and throw it into this data block here. And again, it's going to add that header. Now, when it gets sent down to the data link layer, it's going to create what we call a frame. The frame is what encapsulates all of this information into a header. Now, this header is going to contain our Ethernet address information for physical transmission, but it's also going to give us a trailer. Now, before we go into what those are, just keep in mind that all of this information is now in this data block here. So it essentially just is a staircase down. Application layer gets sent down to transport layer gets sent down to network layer, and network layer gets sent down to data link layer. This would be our packet, and this will be our frame, okay? Now, our header, again, is with what? Our Ethernet information, our MAC address information. The trailer is something that we're not going to cover in this course, but it's good to know so you don't think there's nothing in it. And that is what we call the FCS field. It is frame check sequence, which just guarantees delivery of our bits across the network. Now, once we have our segment encapsulated into our packet encapsulated into our frame, our information is ready to be sent across the network on the physical layer. That's where physical layer is so important and why we need to understand that it does exist when we talk about data encapsulation. Even though we're only really concerned about segment, packets, and frames for the encapsulation process, without the physical layer, it just physically can't be transmitted across the network. And this is where all our bits of data, so all these different binaries and ones and different zeros, send this information to another device on our network so we could have network communication. So you got to see the TCP/IP model in the two versions, and you are also able to see the layers and how they are similar to the OSI model. And you are also introduced to segment, packets, and frames for our data encapsulation process. Now, we will talk about segments, packets, and frames more later on in the course, but at least now you are familiar with them. So if you have any questions, please use this time to ask your questions or leave your comments. Also, please don't forget to check out Learn Tech Training on YouTube for free lectures, labs, and promotional offers for future courses we offer. I will see you guys in the next lecture.